Okay. Now we will do some problems based on the continuous function. Okay, based on the continuous function. First question. So that the function f of x was 1 over x if x not equal to 0, 0 if x equal to 0 is continuous for every real x. Here we want to check for this case continuous or this case also continuous. For case 1, x equal to 0, this case. Therefore, your function is f of x minus f of 0. F of x, f of 0, here f of x take the value x was 1 over x minus f of 0, 0. Therefore, you have x cos 1 over x. Okay, x cos 1 over x. This one should be less than equal modulus of x. Why? Because cos modulus of cos of x should be less than equal 1. Okay, less than equal 1. Now, let epsilon greater than 0 be arbitrary. Okay, arbitrary. We have modulus of f of x minus 0 less than equal modulus of x for all x satisfying which condition? Modulus of x, because x minus 0 means modulus of x less than delta. Okay, now we put delta. Okay, now you want to show that this modulus of x, you want to show that for the continuous function f of x minus f of 0 less than epsilon. Therefore, from this step, you have modulus of f of x minus f of 0 less than equal modulus of x. This one less than delta. Now you want to choose delta equal epsilon. Delta equal epsilon for greater than 0, right? Delta equal epsilon, we have, exist delta greater than 0 such that f of x minus f of 0 less than epsilon, right? For all x satisfying, okay, x satisfying modulus of x minus 0 less than delta. Okay, x minus 0 less than delta. Right, since epsilon greater than 0 be arbitrary, therefore the result is true for all epsilon. Therefore, for all epsilon greater than 0, there exists delta greater than 0 such that f of x minus f of 0 less than epsilon for all x satisfying modulus of x less than delta. This means that is f is continuous at x equal 0. Now your case 2, x not equal to 0. Right, x not equal to 0. X not equal to 0, for this case, you take one of the function g of x equal 1 g of x. 1 over x, and for x not equal to 0, no, it's therefore x not equal to 0 means this is well defined, and also h of x cos 1 over x. Okay, h of x you take cos x, right? H of x equal to cos x. Now you consider composition function h composition g of x. This one h into g of x. H into g of x means yeah, g of x 1 over x. Now your x is 1 over x, therefore you get cos 1 over x. Cos 1 over x. Okay, right. You already studied, suppose f is continuous function, g is continuous function, therefore this f composition g is continuous function, like that here. G is continuous function, x not equal to 0 case, and also h of x also continuous function, therefore h composition g also continuous function, right? It is continuous function, expect x equal to 0, right? Since g of x and h of x are continuous functions, right? Continuous function. Therefore, h composition g is continuous function for all, right, x not equal to 0 important, right? For all x not equal to 0. For any values of x satisfying but not equal, x not equal to 0, right? X not equal to 0 when other numbers should be satisfying, right? H composition g is continuous function. Okay. Now, your claim is you also that this is continuous function. X not equal to 0 case. You know, suppose f is continuous function, g is continuous function, the product function also continuous function. No, we use that fact here. Therefore, you take f of x. Right. This x cos x now your function. We prove this is continuous function, cos x 1 over x continuous function. X another function. You take mx x. F compulsory. Mx. Therefore, since obviously this x is continuous function, right? X is continuous function, and also cos 1 over x already proved is continuous function. Therefore, f is continuous function. Since m of x is continuous function and this h composition g is continuous function. The product of two functions is continuous for x not equal to 0. Right? For x not equal to 0. Okay, right. It is the question, right? It is the question. For all values of x is continuous, okay, that means x is equal to 0 case also continuous, other points not equal to 0, expect 0 case also continuous, therefore all values of x, this function is continuous. Okay, all values of x, this function is continuous. Okay, now we do another problem. So that the function is discontinuous at x equal to 0. The function is defined by like this: f of x equal sine 1 over x. X not equal to 0. 0 if x equal to 0. Okay. For this part, right, we'll do like this. What is the value of f of 0? F of 0 means 0. X equal to 0 case. Now we use the sequence here. Let Sn be a sequence number, right? Sn be a sequence, and Sn be a sequence, and for this case, choose Sn equal, you will assume that this value is 2 over 4n plus 1, 5, right? Then suppose this value is Sn equal to this sequence, then Sn length to 0 as n length infinity. Okay, Sn length 0 as n length infinity. Now you take the f of Sn value. F of Sn means sine, you already, the theorems somewhere else you studied this, Sn not equal to 0 important. Therefore this case, sine 1 over Sn. Now you put Sn values here, 2 over this one, you get 4n plus 1 pi by 2. You simplify this one, you get 2n pi plus pi by 2. Sine 2n pi plus pi by 2. Sine, sorry. Yes, sine there inside. Sine function, sine 2n pi plus pi by 2. Right? Sine 2n pi plus pi by 2. Sine 2n pi plus pi by 2 again, sine pi by 2. So our sine pi by 2 should be 1. Okay, sine pi by 2 should be 1. Now you take the limit. Now you take the limit. Limit of n length infinity f of an. Limit of this value is 1, n length infinity, again 1. For continuous, we have the theorem, suppose this f of an lends to f of a, it is continuous. What is f of a? It's not equal to 0, equal f of 0. Therefore, it is not a continuous function. Therefore, f is not a continuous. That means f is discontinuous at x equal to 0. Therefore, f is discontinuous at x equal to 0. Okay, discontinuous at x equal to 0. Next question. So that the function f defined by the function f is defined by f of x minus x if x belong to rational number, if s does not belong to rational complement, irrational number. You want to show that this function is continuous only at x equal to 0. Is continuous only at x equal to 0. Therefore, only at x equal to 0 means your line, only your point x equal to 0, other points discontinuous, only x equal to 0 is continuous. Okay. Case 1, x belong to rational number. Let epsilon greater than 0 be arbitrary. Epsilon greater than 0 be arbitrary. What about this value? F of x minus f of 0. f of x minus f of 0, f of x equal to x. F of 0, put x equal to 0, 0. You have modulus of x. You put, okay, for all x satisfying, which condition? For all x satisfying percent continuous function condition here, modulus of x minus 0 less than delta 1. You put here modulus of x less than delta 1. Therefore, this you are less than delta 1. Choose delta 1 equal epsilon, epsilon is positive. Then you have the directness for delta 1 greater than 0 such that f of x minus f of 0 less than epsilon for all x satisfying x minus 0 less than delta 1. Therefore, f is continuous at x equal to x equal to x equal to 0. Understand? Now we prove f is continuous for this case. Next we prove f is continuous for this case at x equal to 0. Right. This first claim. Now second part, case 2. You take x belong to irrational number. Okay, f is irrational number. Right. Let me do that part. Right. Right. For this case, again, let epsilon greater than 0 be arbitrary. Let epsilon greater than 0 be arbitrary. Okay, now same idea, right? You take again f of x minus f of 0. F of x means minus x. Minus 0. Modulus of minus x, obviously, modulus of minus x again, modulus of x. Modulus of minus x again x, no? Here, for all x satisfying, right, modulus of x minus 0 less than delta 2. This means modulus of x less than delta 2. Therefore, this modulus of x less than delta 2. Okay, less than delta 2. Therefore, now choose this delta 2 equal epsilon like this. Choose delta 2 equal epsilon positive. Then you can tell for delta, there is delta 2 greater than 0 such that f of x minus f of 0 less than epsilon for all x satisfying x minus 0 less than delta 2. Therefore, f is continuous at x equal to 0. Choose delta 2 equal epsilon, then there exists delta 2 greater than 0 such that f of x, f of 0 less than epsilon for all x satisfying x minus 0 less than delta 2. This means that is f of x, this means that is f is continuous at x equal to 0. Choose here be from the first case and second case, choose the minimum delta equal delta 1. Second case, delta equal delta 2. Now you choose the minimum of, for this both cases, delta, we assume the delta, it is minimum of delta 1, delta 2. Right, delta 1, delta 2, that means for all epsilon greater than 0, their x now to delta 1, delta 2 becomes delta greater than 0, such that f of x minus f of 0 less than epsilon for all x satisfying x minus 0 less than delta. That is, therefore, f is continuous at x equal to 0 for each cases. Okay. Only x at x equal to 0. Therefore, you want to check other cases also. Okay. Okay. Now, to take another case, case 1, that is, suppose you take one of the element a belong to irrational number, but a not equal to 0. Then, since it is irrational number line, it is irrational number, you take one of the point here, a plus 1 over n, here a minus 1 over n. So obviously this value exit, right? A minus 1 over n, a plus 1 over n, for all n belong to natural number. This condition should be exit. For n belong to natural number, right? From at this interval, at these 2 points, you can find then one of the irrational number like a n. Therefore, right? Therefore, therefore, they are like this. Then irrational number, that is an irrational number, sequence of number, right? Sequence of numbers a n in natural number such that a minus 1 over n, a n, a plus 1 over n for all n belong to natural number. This one implies modulus of a n minus a should be 1 over n for all n belong to natural number. Okay, n belong to natural number. Suppose n lends infinity, this one implies a n lends to a as n lends infinity. Okay, a n lends to a as n lends infinity. Now, now right now, what about this f of a n value? F of a n means here a n, right? What is f of a n value? F of a n means here f of a n here for the a n is irrational number, therefore minus a n. Then you take the limit n lends infinity, limit of minus a n, n lends infinity, a n lends to a, therefore it's minus a. For a Biot theorem, the sequence limit should be this f of a only is continuous. Therefore, now here, what is your f of a? A is a rational number, therefore f of a equal a. It's not equal to a. It is your f of a. F of a because a belongs to rational number. So it's not equal a. Therefore, it's not satisfying. Therefore, f is not continuous at a belong to irrational number, but a not equal expect 0 value. That means discontinuous. Discontinuous at, okay, discontinuous at x equal to, x belong to rational number but not equal to 0, expect 0. Now for case 2, you assume that here a belong to irrational number. Here also a not equal to 0. A belong to irrational number. Right? A belongs to irrational number. Then same idea, since obviously here your a there, here a minus 1 over n there, here a plus 1 over n there, for all n belong to natural number. Since a minus 1 over n, a plus 1 over n, for all n belong to natural number. Therefore, there it is rational number. There it is rational number a n such that a minus 1 over n, a n, a plus 1 over n, for all n belong to natural number. From this one implies, you're wrong. From these two numbers, you can find the such one of the uh, first case, you find the irrational number. Here, rational number. This a n belong to q. Here, a n belong to q complement. Here, a n belong to q. Okay, therefore, it implies a n minus a less than 1 over n for all n belong to natural number. This one implies a n lends to a as n lends to infinity. Now, f of a n. Your a n, now your a n is rational number, therefore f of a n means rational number, f of a n become a n. Now you take the limit f of a n, n lends to infinity. Limit of a n, n lends to infinity becomes a, because a n lends to a. But you want to show that for a continuous function, this limit of n lends to infinity, f of a n equal to f of a. Right. Your f of a value is which one? A belong to irrational number, therefore f of a means minus a. Therefore, it is not equal to minus a because it is f of a. Is condition not equal? Is by equal is continuous, not equal discontinuous. Therefore, f is discontinuous at x equal, sorry, a belong to irrational number, expect a not equal to, expect 0. Okay, expect 0. Therefore, at these two cases, discontinuous, expect 0 values. Therefore, only f is continuous. Therefore, f is continuous only x equal to 0. Right? F is continuous only x equal to 0. Other cases, discontinuous. Okay, right. Now we do the another problem. Okay, now we do the another problem.